Good morning. Today we're going to talk about section 4, which is on page 18 in your notes, so please get there. We're going to talk about using matrices to represent transformations. So you guys learned about transformations back in geometry. You learned about translations, which are called just like a slide, reflections, where you flip over a line, rotations, where you turn, usually about a point, and then dilations, when you have a compression, so something that gets smaller, or an expansion. So we're going to talk about how we can represent figures using a matrix, and then also how we can represent those transformations using matrices. So when we have a figure, so we have here figure A, B, C, we're going to represent each of those points with what we're going to call a point matrix. So the point XY we're going to represent with a matrix, which would be just a 2x1 matrix. So for the matrix, for the triangle ABC, we're going to have a 2x3 matrix. So it's always going to be 2 rows, and it's always the x's go in the top and the y's go in the bottom. The number of columns would depend on how many vertices there are. So if it was a quadrilateral, you would have 4. So the coordinates for A, I know that's kind of hard to read, but the coordinates for A are -2, 4, and then for B is 0, 6, and then for C is 1, -1. So you can see that I'm putting the X value in the top and then the corresponding Y value in the bottom. Okay? And so triangle ABC, so what does it seem like has happened to triangle ABC to get to this triangle A prime, B prime, C prime? So it looks like it's just been translated. There's been some sort of slide. So we want to think about how it's been slid. So think from like A to A prime, what's happening? So we're going to the right 3 and we're going down 2. So we're going right 3 units and down 2 units. And then we can represent triangle A prime, B prime, C prime. So if we were at -2, 4 and we went to the right 3, it's as though to this matrix A, B, C, it's as though we're adding 3 to the X and we're subtracting 2 from the Y. And we're going to do that to each point. So I'm going to need a 2x3 matrix, and this is going to represent my translation. So sometimes you'll be asked for the translation matrix. That would be our translation matrix in this case. So when I add these 2 matrices, that gives me my image matrix. So this would be 1, 2 for my A prime, and then 3, 4, and then 4, -3. Okay, so again, when we compare those matrices, if we add the matrix that was all 3's across the top and all -2's on the bottom, we get the second matrix. And this type of matrix is called, like I said, a translation matrix. And in this transformation, triangle ABC is the pre-image. So what we start with is called our pre-image, and triangle A prime, B prime, C prime is called the image after the translation. So you should remember that vocabulary back from geometry. Okay, so we're going to take a look at example 1 on page 19. If you need a little bit more time, feel free to pause and rewind, and you can look at those again. All right, so now example 1 says, suppose quadrilateral RSTU with the following vertices is translated 2 units to the right and 3 units down. Represent the vertices of the quadrilateral as a matrix. So RSTU, and so again, the X's go in the top, the corresponding Y's go in the bottom. And then the translation matrix. So if I want to go 2 units to the right, I'm going to add 2 to all my X's. And I'm going to subtract 3 from all of my Y's. Excuse me. So here's my translation matrix. Now, sometimes like on the homework, it will say use matrices. Like I know that you guys could probably do that translation without necessarily using a matrix, but pay attention to the directions because sometimes it will say specifically to use matrices to show the transformation. So then when I add those together, that's going to give me my image. Okay, so then if I do our calculation here, we would have, this would be, I'd have 5, and then I'm going to subtract 3, so -1, and then this would be 9, 1, and 11, 5, and 7, 3. Okay, and then you're asked to graph the quadrilateral in the image. Now looking at these ordered pairs, it's not going to fit if I go by ones, so I'm going to go by twos so it all fits. Okay, so go ahead and take a minute and get everything graphed, and then if you need to pause so that you can get it graphed because I'm going too fast, and you can do that. And make sure you label as you go so that you can keep everything straight. Okay, so there's my pre-image, and then I'm going to graph my image. So I've got my pre-image and my image. Okay, so now we're going to get into the reflections and the rotations. Okay, so to do this, we're going to kind of do a little bit of an investigation. So it's asking you to reflect the point 1, 2 over the x-axis. So first let me plot the point 1, 2. So everybody plot the point 1, 2. And then it says, okay, reflect over the x-axis, and then how did the coordinate change? So we're going from the point 1, 2 to the point, if I reflect over the x-axis, so that means the same distance from the x-axis on the other side, I'm going to end up at 1, -2. So 1, -2. So what happened is that these became, the y values are now opposites of each other. And so what I want to do is I want to figure out a matrix operation I could do to get from this point to this point. So I want to think, what matrix could I multiply by 1, 2 to end up with that new coordinate? So I want to multiply this matrix, 1, 2, by something, and I want to end up with 1, -2. And whatever rule we come up with would have to work for any point. So I can't just figure out a rule specific to only 1, 2 going to 1, -2. It has to work for everything. Okay, and so we talked yesterday about matrix multiplication and how that works. And so if I want to multiply something and the dimensions of it are a 2 by 1, and then I want to end up with something where the dimensions are also 2 by 1. So I need to figure out first, do I want to multiply by something on the left or on the right? So if I multiply by something on the right, remember the inner dimensions have to be the same. So this would have to be a 1 for that matrix multiplication to even exist. And then the resulting matrix comes from like these outer dimensions. So if this is a 2 and I want a 2 by 1, this would have to be a 1. So that means this would have to be a 1 by 1 matrix. And then I want to end up with 1, -2. So we want to think, okay, is that possible? Is that where I want my matrix? Well, I could only have one number here. So is there a number I could put here where when I multiply by 1, it gets me this, but when I multiply it by 2, it gets me that? That's not possible. Okay, so that's not going to make sense to put the multiplication on the right. So now let's think through this. If I were to put my matrix on the left over here, and again, this is a 2 by 1, and this is a 2 by 1, then for this multiplication to work, these inner dimensions have to be the same. So this has to be a 2. And then the outer dimensions have to be the same as this. So there's the 1, so this would have to be a 2. So what it means is I need to have a 2 by 2 matrix over here so that when I multiply it, it's going to change 1, 2 to 1, negative 2. And again, whatever matrix I put over here would have to work for any point. So if my original point was 4, 5, and that would mean if I flipped it, I would get 4, negative 5. Whatever matrix I use has to work for any point when I reflect it over the x-axis. And so why don't you pause the video and take a couple minutes and try to figure it out. And then when we come back, after a couple of minutes, then we can see what you came up with. Okay, so I'm curious to see if anybody figured it out, but I'm not there, so you'll have to tell me tomorrow about what would work. So remember, matrix multiplication is you do the row times the column, and you multiply this pair, whatever's here times 1 and whatever's here times 2, and when you add them together, you have to equal 1. Okay, so basically it's like I want to keep this 1 the same, so I'm going to multiply it by 1, but I don't want the 2 at all. I want 1 plus nothing, so I'm going to multiply by 0. Right, so here, if I do 1 times 1, I get 1, plus 0 times 2 is 0, and then it adds up to be 1. All right, so now for this next position here, I would do now this row times this column. And really what I want to have happen is just take the opposite of the negative 2. So it's like I need to do 0 times 1, which is 0, plus negative 1 times 2, which would be negative 2. So this matrix, if I multiply by this matrix, it would get them to flip. And that would work also for this one, right? This would be 4 plus 0 is 4, and then this would be 0 plus negative 5 is negative 5. So our matrix for reflecting over the x-axis is going to be 1, 0, 0, negative 1. The way we're going to denote that is with a little r and a subscript of x, or it might be a capital R and it might say x-axis down here. And then so what we kind of want to do is we want to think about, okay, well now what if it was the y-axis? What was it over? What if it was over the line y equals x? We want to figure all of those out. So kind of the same process. So for the y-axis, if I start with 1, 2, and I reflect it over the y-axis, I would end up at negative 1, 2. Okay, so it's like I'm starting with 1, 2. I want to end up with negative 1, 2. Okay, go ahead and pause and see if you can come up with it. Okay. And so what it ends up working is, because I want the opposite of the 1, but I don't want the 2, this would be a negative 1 and a 0. And then I want to keep the 2 the same, so this is 0, 1. So for all of these, they're all going to end up being combinations of 1s and 0s and negative 1s. Okay, so I'm just jotting that matrix down here to have in general. Okay, and then reflecting over the line y equals x. So here's the point 1, 2. The line y equals x is that one that goes right through the middle of everything, right? Slope of 1 and y-intercept of 0. And what happens is that the points interchange. So 1, 2 reflects to be at 2, 1. It's like flipping over that line right there. So I'm starting with 1, 2, and I want to end up with 2, 1. And so if I want these to interchange, it's like I don't want the 1, so it's 0, but I want to keep the 2, so it's 0, 1, and then 1, 0. Okay, so this would be reflection of y equals x like that, or capital R. And our matrix would be 0, 1, 1, 0. And I know you guys are going to ask, do we have to memorize these? And you need to be able to generate them, and I am going to show you a way to be able to do that pretty quickly. Okay, so now let's talk about rotations. So we could do the same idea for all of these rotations. So we're going to talk about rotations of 90 degrees, 180 degrees, and 270 degrees. So if I start with the point 1, 2, and then I rotate 90 degrees, I'm going to end up over here at the point negative 2, 1. So I'm starting with 1, 2, and I'm ending up with negative 2, 1. So it's like I want them to flip, like switch spots, and I want to end up with a negative 2. So I want to, like, so when I do this multiplication, it's like, I don't want the 1, I want the opposite of the 2. So this is going to be 0, negative 1, and then 1, 0. And then for this one, we're rotating 180 degrees. So here's 1, 2. And now I want to go like kind of directly across here, 180 degrees. So I end up at negative 1, negative 2. So I'm going from 1, 2 to negative 1, negative 2. So it's like the same thing, but I want opposite. So this is going to be negative 1, 0, and 0, negative 1. All right, and then for the last one, I want to go 270 degrees. So I want to go like all the way to here. So I'm going to end up at 2, negative 1. All right, so there's my 270 degrees. So I'm starting at 1, 2, and then going to 2, negative 1. So again, they're flipping, but now I want the opposite of the 1. So I'm going to have 0, right, 0, and then I want plus 2, so 0, 1 here, and then negative 1, 0. Okay, so let's get those all in this table. And we would denote that with a capital R with a subscript of 90 degrees or 180 degrees or 270 degrees. Okay, so now, like I said, you're probably wondering, how am I supposed to remember all this? So we have something called the matrix transformation theorem. And we're going to think of it as always starting with like almost our identity matrix, the 1, 0, 0, 1. So it's as though we're starting with 1, 0, 0, 1. So sort of think of that as our identity matrix, and that's X and that's Y. And I want to know what happens to this over some transformation. So I'm thinking, like, what happens to the point 1, 0? It's going to become some point, x1, y1, over the transformation, right? And then I have the point 0, 1, and I'm going to think, okay, what happens to that? And I'm going to call that point x2, y2. And then I'm going to take those, so over our whatever our transformation is, and create a new matrix. So whatever happens to the point 1, 0, that's going to go in the first column, and whatever happens to 0, 1, that's going to go in the second column. So I'll show you what I mean by that. So example 2 says, use the reflection matrix to find the coordinates of a reflection over the y-axis of this square with these vertices, and then graph the preimage and the image. Okay, so first I'm going to come up with a matrix. Let's say I don't remember it, it's a test, I don't have it in front of me. So I'm going to figure out, okay, what happens to the point 1, 0? So I'm going to just do a little sketch over here. Okay, so if I take the point 1, 0, and I reflect it over the y-axis, it lands over here at negative 1, 0. Okay, so this becomes negative 1, 0. So that's going to become, when I go to do my matrix for a reflection over the y-axis, that's going to become my first column. Okay, then I'm going to figure out what happens to the point 0, 1 when I reflect that over the y-axis. So you can put that little y, r sub y, so you remember that's what you're doing. Okay, 0, 1 is right here. Okay, if I reflect that over the y-axis, well, it's on the y-axis. It just stays the same. Okay, so this right here went in the first column, this one is going in the second column, and that's my matrix, right? And that was the matrix that we had written down before on the other side. So there's my matrix, and then I'm going to write my vertice matrix for the quadrilateral, and then I'm going to multiply to get my pre-image, or my image rather. And I guess you could put this in your calculator, but remember what's really happening is you're taking the opposite, because it's always going to be negative 1 times this plus 0, negative 1 times this plus 0, and so on. So it's really like you're just taking the opposite of the top row, and then the bottom row is staying the same. And then you can plot the points. And again, just make sure, and I think I'm going to go by, am I going to go by 2s? Sure, I'll go by 2s. Remember, if the directions say to use matrices, you really need to use matrices. So then you're going to plot your points. So there's that one, and then 8. And this one. Why does that one not look right? 2, 4, 6, 8, 9. That's right. Okay, there's my square. It doesn't really look like a square. Okay, and then the other one, we're reflecting. So -4, and then 1, and then 2, 4, 6, -7, 3, and then 7, and 9, 0, and then 6, -2. All right, and then example 3, we don't have to graph this one, but it is asking for us to figure out the rotation. And again, we can practice that matrix transformation. It says find the locations of these points at 90 degrees, 180 degrees, 70 degrees, 270 degrees. Let's just do one of them. Let's just do, let's say, the 270 degrees. So if I wanted to figure out that matrix, again, I would start with, okay, what happens to the point 1, 0? So it helps me to do a little sketch so I can visualize that. So here's the point 1, 0, and if I go 90, 180, 270, I end at 0, -1. Okay, that's going to be the first column of my matrix. And then if I take the point 0, 1, which would be here, and I go 90, 180, 270, I end up at 1, 0. So then that becomes the second column of our matrix. So here's the second column, this is the first column. And always goes from 1, 0 to 0, 1. And so that's our rotation of what we said, 270. And then we're going to multiply by this point matrix. So I'm going to do that. And then find my image. Okay, so what's happening is like 0 times this plus 2, 0. So this whole row is moving to the top. So you could, like I said, you could put this into your calculator, but really once you kind of figure out the first couple, you're like, oh, this is just opposite plus 0, opposite plus 0. So the top row is coming to the bottom, and then you are taking the opposites. This helps to line things up. Okay. All right, and then the very last transformation was a dilation or a compression, right? Remember, we talked about having dilation. So that's a compression or an expansion. So it's when something gets bigger by a factor or smaller by a factor. So we have a parallelogram. And they give us our vertices, so I'm going to go ahead and write my matrix. And then find the coordinates of the dilated parallelogram for a scale factor of 1.5. So it's getting 1.5 times bigger. There are a couple of different ways we could do this. Like when they say scale factor, that's like multiplying by a scalar. So you guys are probably thinking, oh, I could just multiply everything by 1.5. And you really could. If we wanted to think about a matrix, though, what we could do is, if I want everything to be multiplied by 1.5, I can't do 1.5, 1.5, 1.5, 1.5, because that would multiply everything by 1.5 and then I add it. So it's like I would want to do 1.5, 0, and then 0, 1.5. And in either case, you're going to get the same thing. So we would get, double U prime, so -3, 6. So everything basically is getting multiplied by 1.5. So x prime would be 0, 12. Y prime would be 6, 9. Z prime would be 3, 3. And then we could go through and graph everything. I'm going to go by 2s because I see I've got some going out to 12. So let's see, I've got -2, 4, 0, 8. Oops, that was a W. W, X. All right, then 4, 6, and then Z. So here's my original, and then multiplying by 1.5. So now I'm at -3, 6, and then 0, 12. and then 6, 9, and then 3, 3. And then, whoops, there we go. There's our 1.5 times. Okay, so lots of practice with matrices and then putting that together with transformations. So your homework is 2-4. Make sure you're following the directions. If it says to use matrices, you should be using matrices because that's what you would be expected to do on the quiz. I will see you tomorrow and answer any questions that you still have. Have a great day.